Hi, let's talk about internet. You see this picture. The internet is the network which you use your mobile phone to connect it to. Once you connect your mobile phone to internet, your mobile phone can be called a smartphone. Internet has tons of information. Based on the information, you can make a good decision that make you look smart. So we call smartphone. Smartphone is a mobile phone have a data plan which connected to internet. Internet showing like a cloud. It's in everywhere, but it's nothing under the cloud. It's physically under the earth, somewhere, maybe in Dallas, maybe in Japan, maybe in Europe. They have a physical location, physical devices. The broadcasting channel can be via satellite, that's microwave, can be via cable, under the sea, or under the land cable. That's both ways. And they can also use the PLMN network. That's called public land-based mobile phone network. Meaning you can use a Wi-Fi, connect to a LAN, connect to internet service provider, or you can use your mobile phone to connect to a tower. That's a base station. Then the base station connect to a telephony switch. We call it MSC, Mobile Switching Center, connecting to the internet. Let's check about the internet. This one says that the internet connects billions of people and organizations all over the world, which is a true statement. The first question we may want to ask is who owns internet? Internet is owned by no one and owned by everyone. For example, you have created something under Wikipedia. That piece of info is owned by Wikipedia and also owned by you. Owned by you, you can delete it. That's called internet. YouTube, that's under internet. You post your singing under YouTube, that's belong to YouTube, which right now has been acquired by Google, belongs to Google and also belong to you. You can go there and delete it. If Google so find it's inappropriate, then the Google can delete it. That's why I'm saying the piece of music or singing you have posted under YouTube is belong to YouTube and you yourself. For this couple of examples, we understand everybody owns a piece of internet, and internet is not really owned by one big organization. No, not the case. The first question. The second question may be who created internet? Internet was created 1970s by the United States. By which organization of the United States? By Department of Defense, DOD. Okay, now we're figuring out which organization created the internet. We may want to ask why this organization created internet. Why? DOD back to 1970 using computers in different locations. Computer is useless unless they have some data, turn out to be some info, and info can help people to make some decisions. Those data have to be updated. The computer is only useful as long as the data can be accessed and updated. There are tons of new information. Some data need to be corrected, some data need to be added, some data need to be deleted. How can we make all the military-based computers in sync? In sync meaning when I update computer 1 with certain data, computer 2 and 3, preferably at the same time going to be updated with the identical data. How can I do that? Without internet, it cannot be done that way. It can be done, maybe I pick up the phone, I am in the military computer A, I call people in military computer B and C, then talk to them and say, hey, type this in, and in a hexadecimal format, what I need you to type in is H12B34CF2490AC. That's hexadecimal format. My pronunciation and what you're hearing may cause some problem. We are only human. Even we don't cause any problem, it's going to be slow. And with tons of info, it's infeasible. It's like impossible or very, very difficult for us to do that. Then we need something else. That something else was called internet. The government at that time, 1970s, they don't have expertise to come up with a internet. So they have a funding called DARPA, DARPA, this funding, and ask some school like USC and those schools, west side of US, say, hey, you guys, you are computer science professors, could you come up and develop something nowadays we call internet? Surely, so they did it. They make it work, and make it work. That's based on the TCP and IP, we have internet. And the first two application of internet, one is email. I am at computer A. I'm sending an email to computer B, C, D, E, F, G, all at the same time. That's the first application of internet is email. And the second application of the internet, almost at the same time, is the file attachment. I have attached a file. Please upload this file to your computer. Once people in computer B, C, D, E receive this email, they updated the computers with my attached file. So, I mean, it's not going to have any problems. It's going to be error-free, and it's going to be like very fast. I'm not going to say real time, still some processing time, but that's going to be very, very fast. That's why we comes with internet. Today, you are using internet. Are you using email? I think so. Are you attach files for your email sometimes? I think so. Those are two original applications of internet, email and attach file. Now you know why. And that's when we have internet. Once we have internet, after about 10 years, companies like IBM asked the government, US government said that, hey, I don't have any military computers located in different locations, but I do have computers, that's business computers, located in different locations. Could I use the way you use? Today we call internet. The government said, yes, you may, and I'm going to let you know how to do it. How to do it, basically, it's called TCP/IP protocol. I'm going to give it to you. When I say give to you, is to open up an organization to give to all the companies, IBM and other companies, and that organization is called IETF.org, O-R-G, Internet Engineering Task Force, IETF, Internet Engineering Task Force.org. So if you talk to me, say, Professor, I know everything about internet. I have Googling, I have read all the internet info published under Wikipedia. Yes, you have the knowledge of the internet, but I'm talking about industrial. The industry, they use, we call spec, standard. They use standard to test, to design their internet. They are not using anything based on Wikipedia. Wikipedia, everybody can be an author of Wikipedia. Wikipedia's info change like every minute. I have something posted under Wikipedia, and I change it several times already. So we cannot be based on Wikipedia to design or testing anything, we need to base on a standard. Standard posted there, it will not be changed. Once we have something new, we give a newer version and indicate this newer version replace the old version. That's not change. We isolate. We obsolete the old version, and we said that you need to use a new version. That's one way. Another way is, in addition to the old the version AB 123, now we have a version called 125. Both added to 123. You need to use both versions. It's not obsolete, but now we have two versions. One is the original one have additional information. If you design and test, you have to be based on both. I was in the industry for 15 years, and I do use IETF.org standards such as TCP/IP to troubleshoot and to design a company's network, like MCI, Ericsson, Nortel, and to troubleshoot. I do not use things under Wikipedia. So am I saying that things or info under Wikipedia is useless? No, I didn't say that. Am I going to say that? No, I'm not going to say that, because which is not true. Info under Wikipedia is a very, very good starting point. You want to understand what's internet, Wikipedia, internet. But if you want to know the standard, you're working for the industry, you want to do a design, testing, troubleshooting, then you go to the standard. You can never be based on the Wikipedia and to write a trouble report. I did wrote trouble report to company Ericsson, Nortel, and to say that, hey, based on IETF.org TCP, that's 729, something like that number, the standard number. And the switch, your switch is supposed to be work this way, but it works that way. Now you need to fix it. Okay, so they fixed it. I mean, I can never say that based on Wikipedia and your switch have to be work on this way. No, so that's a simple idea. If you want to know a guy knows internet or not, that's Wikipedia will work. But if you want to know the guy work in the industry to do the design, testing, troubleshooting of internet, that guy, that person have to know IETF.org, the standard body. And that standard body is open up to general public. Anyone in the earth can access internet, can see those documentation. It's for everyone, totally free. There's no charge, no nothing. So if you know IETF.org, you know the internet from the industrial standpoint. If you don't know, you don't know internet from the industrial standpoint. That's my basic I want to share with you for internet. Now we come back to the history again. The history says 1969. That's very, very close to 1970. So if I use 1970, that's 1 year difference. And the government have a DARPA, DOD, have a ARPA, Advanced Research Project. That's we call DARPA, Department of Defense. DARPA, that's project. That project going to build out something like internet for the government, for the military. The picture shows you the reach of ARPANET, 1971. After 2 years, they built up the first, you may say that's the very first internet. That internet is called ARPANET. And from here, you can see they're showing you some cities in the US West Coast, some cities in the US East Coast. Then they can talk to each other. When I say talk, meaning email attached file, sending information. DARPA project, 2 years, completed this ARPANET. This is the very first internet. You need to create a standard. Thinking about internet is nothing but a highway system. US have highway system. In highway system, you need to have physical road. Other than that, you're going to have lots of sign. Say this is the I-20, that's 75, I-75, and speed limit, and merge, that kind of stuff here. Highway, typically they may put a sign says speed limit is 70. Without that, it's going to be difficult for people to drive. The same thing happened for internet is they build out some cable, thinking about those are all the cables here. That's your highway, the roads, and regulation, your speed limit, something like that. That's your TCP/IP. Without TCP/IP, it will not work. And here we have an example for TCP/IP. The top 192.168.1.101, that's IPv4. Below FE80, column D, 14B, column 58C, column 1E50, column 217F, that's IPv6. IPv1, B2, B3, we don't use it. We only have IPv4 and IPv6. You may want to ask, why is that? Why you don't have IPv1, IPv2? V1, V2, that's version. Why you skip those version and you have IPv4 and IPv6? It's very, very simple. We're starting with IPv1, version 1, version 2, version 3, version 4. Then we're figuring out, whoa, version 4 is good enough. Then we'll use version 4. Then later on, we want to enhance the security. So we have IPv5, then we have IPv6. IPv6 is good enough. Therefore, we use two versions, IPv4 and IPv6. IPv4 came out 1970, the first version, IPv4 we use. It's not really have lots of secure consideration. In this case, we use IPv6 to address the problem. You see that FE80, that's one reason, much more secure. Number two is they have more IP address. The top one, 192.168.1.101, 3-digit, .3-digit, 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 0 to 9 digit number. And below, you also have A, B, C, D, E, F. That's alphabetical, alphanumerical, and 0 to 9. You can accommodate much more address. We need more address. IPv4 don't have enough address for us. Nowadays, a telephony switch, a phone company's switch may have 20 IP address. Even at home, your freezer may have 1 or 2 IP address. The outside, your air conditioner may have 1 IP address. So all the devices, machine, they need IP address. This way, we go to IPv6. But we are not running out of IPv4 yet. We are not. Companies migrate to IPv6 for better security purpose here. And they are companies, they already migrated to IPv6, and there are more companies stay with IPv4. Still work fine. You don't have to change to IPv6. Something we call protocols. Protocols is a term like IP, P, that's protocol, internet protocol. So what is a protocol? How you define or describe a protocol? Protocol, to me, is a timed event. And how we want to treat this timed event. Let me reword it. Protocol is the consensus how a timed event will be treated by 2 or more than 2 parties. One more time. Protocol is consensus of timed event will be treated, how the timed event will be treated. between two parties or more than two parties. Let me give you some example. If you are using your computer to send out a printing request to your printer, that's timed. Timed event means what's happening before. That something happened. Later on, your computer or you send out another request. Say, hey, where is my printout? Where is my printout is the event to your printer. Your printer will come back, says, hey, already printed, or it's in the queue, something like that. Another scenario, your computer, your printer, you haven't sent out a printing request. You don't do nothing. You just send a request to your printer, say, hey, where is my printing result? And the printer will get confused. Say, hey, you did not send anything to me, or I did not receive anything to you. So what you're talking about status? I don't have that request. Say, I don't know what you're talking. The same event, where is my printout? Based on previously what happened. Previously, I have sent a request to print, or previously I did not. The response will be different. And once we both agree, my computer and my printer both agree. If a request is sent to you, you need to come back with something that got printed already. It's on the queue, it's waiting. You cannot send it to me, say, hey, where is my job? Unless you lost it. So if you respond, well, based on our consensus, if the printer responds, I don't see any task, then your computer say, I really sent it to you, I know that, but you didn't receive. Okay, maybe somewhere lost. So I'm going to resend you one. So that's going to be based on the consensus of a timed event. Event is different. That's timed event for protocol. So protocol is not how we agree going to treat a event. No, a timed event. Another example, you saw your friend. You say, hey, what's up? And your friend say, not much. Then you said, you want to see a movie? And your friend say, nope. Then later on, you chit-chat about something else. Then you said to your friend, what's up? Now your friend really get confused. I mean, why you say what's up? When we first met, you say what's up. I understand. But that's timed event based on previous what happened. Previously, we have chit-chat something, then you ask me about what's up? What's going on? How's life treat you? I'm totally confused. You're not supposed to ask me. We do have a consensus, like both agreed when we talk, that's how we talk. So what's up? That's a event. Based on the timed event, the both sides know how the event will be treated. That's protocols. TCP/IP are two protocols, the most important protocols. To understand TCP/IP, an analogy will be easy. IP, as you can see, 192.168.1.101. Analogy is like you're going to send an email, or say you're sending a physical email, a mail. You really send a physical mail, you need to write down the receiver, the address. That's a receiver's address. The street number, city, country, that's the number. That's your IP. Then we can send you something. Since we know TCP/IP, that is like I'm writing you a letter. I'm ask the post office to deliver this letter. I'm using an IP, that's your home address. Then where comes this TCP? The TCP is like that one. During the Christmas season, for example, I'm sending you or mail you some gifts via the post office. Then I write down your address, your name, that's IP, then I give it to you. Is that good enough? No, it's not good enough. I'm missing TCP. What is the TCP here? TCP is the number of transaction. I may mail you one gift, or I may mail you two gifts, or more than two gifts. How do you know you received all the gifts I have mailed to you? You will never know. In this case, I need to use a TCP. I need to name the numbers. I'm going to write down 1 out of 1. Christmas season, you receive a gift from me via U.S. Post Office, and you take a look. Receiver address, that's you, and write down 1 out of 1. I send you one and only one gift, no questions asked. Should I send you 3 gifts? I will write down 1 out of 3, 1 out of 2, and 1 out of 1. If you receive one, you can ask me, maybe pick up the phone and ask me, hey, what's going on? The same idea, if you order something from Amazon, they're going to deliver you whatever you have ordered. You're going to see a package. That package will also have a TCP. What's the TCP? They are going to write down 1 out of 1. Should that be 2 packages? For the one item you order, they have to package in 2 parts. Then you are going to receive 2 packages. One says 1 out of 1. One says 2 out of 2. 1 out of 2. Another one says 2 out of 2. Then no questions asked. It's very clear how many you send it to me. That's the best analogy for us to understand what's TCP/IP. Hey, that's TCP/IP. Do we need that? I think so. I think so. Now, another example, back to the real computer example. You're surfing. You want to see a web page. Okay, so your browser, that may be IE, and maybe Google Chrome, and that browser will go to the website and make a copy for their website front page and bring it back to your computer. Should the website is very fancy and they cannot be back in one part, they have to have 2 portions. The first portion go to your IP address. Your computer browser know, hey, that's me. And it says TCP says something like, I simplify, 1 out of 2. Then that's fine. Another one says 2 out of 2. That's fine. Same transaction, same IP address. Your browser will show 1 out of 2, 2 out of 2. Combine them and show it to you. Now you have the website, web page. They make a copy, you can see it. During this one we call transaction, maybe we need to have 2 packets. Then that's your TCP and IP. Without that, it just won't work. So IP is, your computer have IP address. Yeah, that's me. That's not other guys. They need to know they're all under this internet. So which ones go to which? Routers will route it to the correct IP. Then TCP. For one transaction, how many packets we have. Your browser is smart enough. Should your browser receive 1 to the IP address, says 1 out of 3. Then 2 out of 3. And wait a while, there's no 3 out of 3. Your browser will send back to the website, say, hey, where is my 3 out of 3? And that website will send out 3 out of 3. Once received, your browser will show it to you. That's transparent to you. Your computer have the software that's called browser to do this TCP and IP. Simply put, IP is your address. TCP is the number of packages per transaction. Science research and education. We are also having some difficult or some different network, like CSNet, for different purpose. The very first one for military purpose, later on for science purpose. There are many for companies, corporate. NSFNet, showing you they have some T1 backbone and client network, 1991. That was like 30 years ago. T1 is not backbone. T1 for backbone, that was 30 years ago. Today, if you have T1 backbone, you have nothing. That's very slow. The bandwidth is very slow. T1 only have 1.5, 1.5 megabits per second. That's very slow, T1, very slow. But 30 years ago, that's good enough. 30 years ago, with that kind of bandwidth, you can send email, kind of a slow email. You cannot send video 30 years ago with that kind of bandwidth. Backbone, that was 30 years ago. You're talking about T1 is your backbone, like your highway. We have local, we have main highway. It's T1, that's very slow. Today, you're using the OC, optical category. OC 50, OC or much more higher, optical category. That's higher. We use OC background, we don't use T1 background. T1, this T stands for what? Nobody knows. If you want to say that T is AT&T, that's fine. That was created by AT&T T1. They have 24 channel. Each channel can be used for a computer or a phone. 30 years ago, you have yourself a small company. You have 12 guys, and those 12 people work for you. Each one, they need to have a computer. They need to have a phone. So 12 people with one phone, one computer, that's 2 channels. Total, 24 channels. You can subscribe from AT&T AT1. It may cost you several $1,000s 30 years ago per month. Then the 12 of your workers can use the phone to call a customer, can use a computer to send out email to a customer. That's all you need. That's T1. Thinking about talking, that's voice, and the email, that's text, that's data format. We're not talking about video. Video consume lots of bandwidth. That's your T1. T1 is 24 channels. In Europe, they have similar but a little bit different standard, different bandwidth called E1. E stands for, well, you can thinking about European 1. And in Japan, they have a J1. Of course, in Japan, that's called Japan 1, J1. So T1, E1, J1. That's long time ago. Am I saying nobody uses it anymore? I didn't say that. People are using it currently. So slow. If you have a home office, only hire 2 guys, or you yourself, T1 is good enough. But if you have a company have 200 people, your backbone cannot be T1. So T1 is still used, thinking about by end users. Used to be T1 have 24 channels. If you need 24 people only making a phone call, that can support 24 workers. Today, T1 for 1 people, 1.5. Your internet speed is much higher than 1.5. That's the minimum speed you will need to support 1 subscriber's video need. So you may have T1. It's not for 24 channel, it's for 1 people. So from this case, you can see the improvement or evolvement of internet for the past 30 years, 24 to 1. Commercial use, the backbone, talking about backbone, then used for the military, used for science, used for business, commercial. IBM, they give you a company including IBM. Yeah, company need to use that for those purposes. Today, we also have a school, we have hospital, like all the organization are all using internet. Who owns the internet? I have told you, internet. We have a number here, says 3 billion users around the world. It's a internet. So who owns the internet? Everyone owns a piece of internet. No one owns the entire internet. That's the nature of the internet. Freedom and openness. Yep. Internet is free. Like I gave you information, the internet standard, TCP/IP, published under the standard body we call IETF.org, Internet Engineering Task Force.org. They are all free and open to general public. If you work for a company, your company's website is free to the general public. Is that right? Of course, it is like that. That's called internet. Internet services. Internet services, they have some companies to make it work called Internet Service Provider, ISP. Internet Service Provider, ISP. You need to pay money to the ISP. The ISP is most likely a phone company. That's your ISP. You pay money to the company. The company will route your packets. You send out an email, the email will be chopped off to many packets, going to be routed to the destination. And don't have to be all the packets be routed via the identical route. They can be different. As long as they go to the end user can combine all of your packets, which is your email, and give it to the destination reader to read. World Wide Web is a term today we don't really use that much. At one time, the World Wide Web is a better version of internet, better service. So you said my company's URL, website address is www.abc.com. That's my company's website. And other guy says my company's website is xyz.com. There's no www. This tells us the ABC company have www. They may have a fancier web page, more functions there. Today, there's no difference. In this case, if you ask a person, what is your company's URL, website address? The response is, well, my company's website is efg.com. You don't have to ask the guys in front of EFG, do you have www. Yes or no? No need to ask that. It makes no difference. They may have, they may not have. Most likely they don't have. But they still may have. Your browser, like IE, Google Chrome, Firefox, is smart enough to know they're going to try it for you. You enter in efg.com. The browser will try to match the number, IP address. Once they cannot match to any IP address, they are going to think maybe you have a www dot in front of EFG. They're going to try that. If they try that and found it, they will use it. Same idea. If a company was number is 124.com or www.124.com and just 124.com and you type in www.124, they don't have www.124.com, your browser cannot find a matching IP address. We'll remove that www and just try that 124.com. Found it. Okay. So you have it, you don't have it. If they're going to try it, they don't find it the first way, they're going to try by adding www or remove www to find the mapping IP address, then go there. HTTP, that's a protocol. Protocol is like a format. This HTTP have a function said, hey, HTTP ://124.com. You go to this company called 124.com, that's HTTP, and make a copy of their front page and bring it back, show it under my computer. That's HTTP means. Go to a certain website, make a copy, and bring it back, show under my website. So that's a serving. You're serving under the internet, you type HTTP a lot, column. You also type in HTTPS, S for secure. It's an enhanced HTTP version. So that enhanced is once you use HTTPS, column // some company use this request. Let's say the company is 789, so 789.com. They request you have to type in S, otherwise you don't find it. Once you found it, that your computer is connecting to the server of a company with the name 789.com. That server will keep talking to your computer. Are you there? They want to know it's not a hacker machine. It's not a fake IP address. So from time to time, I say from time to time, maybe every 5 seconds, 10 seconds, it's a short period of time for a human being. It's a long time for computer. The server talks to your computer, computer responds back and forth. Otherwise, the server will say, nah, you probably it's just a hacker. You don't do nothing. You are going to make me busy for a fake number. You are not there. You're nothing. You're nothing there. So they're going to drop you and serve the legitimate, the real users. That's HTTPS. So you do need to know is the company have to use an S or not an S to connect to their website. HTML, that's a format. That's the website format. Nowadays, they have fancier way using the Google or using the Java and other programming language to make it fancy. HTML is the basic one. For instance, you go to the company, we just call abc.com. Then you go to the website, imagine they're going to see ABC. Yeah, that's their company name. And maybe in large font or maybe in color. Okay, so what kind of color? How large is the font? That's HTML going to tell your computer. That's the format. I'm making it up. Something like HTML format. At first, they're going to say, in the very beginning, they're going to say, hey, this is HTML. So once another computer or router receives that's going to read that, going to say, oh, okay, so this is HTML. Okay, I understand. Then based on the HTML format, you're going, if you said color equal to red, I know that's red color. If you say font equal to say 70 equal to 100, I'm making it up, then you know, okay, that's the font size. Okay, so I'm going to show this company's name ABC in a font size 100 and in red color. So that's HTML. You want to be a web developer. Now your boss say, hey, we want to make it smaller font. How small? Say 80. Okay, change to 80. Font size equal to 80. And I want to make it a blue. Okay, change red to blue. So that's how you do. So HTML, straightforward. We still use it. The HTML and CSS code below are converted by the web browser. Browser, your IE, your Google Chrome, into a attractive. Okay, you have blue color, you have red color, different color, a different font size. Parts of a URL. URL stands for what? I don't know. Most people don't know. I mean, I don't know. Okay, so stands for Uniform Resource Locator, which is a URL. URL is your website address. Do you have to know how to spell out URL. You don't. Do I have to know? No, I don't. It's pretty much like IBM. Do you know what does IBM stands for? No, you don't. Do I need to know what does IBM stands for? No, I don't. But IBM stands for International Business Machine. But you better use IBM. You don't spell it out. You talk to your friend. Hey guys, I got myself a new International Business Machine computer. You're going to confuse your friends. Say, what? The URL, the same stuff. You ask a guy, hey, what is your company's URL? That's good. You ask a guy, hey, what is your company's uniform resource locator? This guy could say, whoa, I don't know. So some abbreviation, you just don't want to spell it out to confuse people. URL is a URL. Stands for what? Stands for something, and I don't really care. This is the URL. The left side, beginning with HTTP : // that's a protocol. Then they have a domain, it's news.example.com. .com tells you it's a company. .net, N-E-T, can also be a network or a company. .org, that's organization. .gov, that's government. Hey, you cannot use your company's name, say .gov, government. It's illegal for you to do that unless you are really a government corporation. Then based on that, then you go to, under the US politics, go to the senator race 714.html. That's, we all understand, that's a file documentation in HTML format. Let me think here, .com. Yeah, this .com here. This .com, pay attention, there's a news.example.com. There's nothing. That means this website is under the US. If this website is under UK, you're going to change news.example.com.uk country. By default, it's US. Other company, you have to type in country code like UK or Japan, maybe JP or something like that to know that's Japan. In China, yeah, you need to type two digit to indicate that's a website from China. The same idea. US created internet, so the default here is .us. That's, yeah, I mean, if you don't type in .us, which means .us, yeah, you can do that. I mean, you don't have to. Protocol, we talk about protocol. Protocol, in this case, this guy tells you if you see HTTPS instead, it means a secure, encrypted connection. Yeah. Encrypted is a key. A key is to add extra 0 and 1 to your stream of original 0 and 1. In this case, a hacker still can get it, but they cannot make sense out of it with all those extra 0 and 1. Then we, after encrypt it, we decrypt it. We remove those 0 and 1. Then the receiver can understand. Encrypting, decrypting, we are adding extra 0 and 1. We know the key, meaning we know which 0 and 1s are we added. Then we remove it. That's encrypted, decrypted. Domain name. This tells you what kind of a company, your company name, what kind of company is the .com, .net, .something. .com don't have to be a company. You can have your own URL, your own website. Your name is John Doe. That's fine. john.doe.com. Yep, you can do that. You say, no, I don't, com sounds like a company. I want to have a personal website. There's no such a thing. You have to choose. You choose .com, .net, that's about it. So something like that. So .com, sometimes you see something .com, maybe just an individual website. I have my own website. It's my name .com. So the .com, not necessarily meaning this is the company website. folder files. Yeah, under the URL, there's a file organization. You go to this folder, US, go to politics, this folder, then you see a file called Senator Race 714.html. Whoa, we talk about email, huh? Electronic mail service. Oh, just an email. Email is an email. And spam. Spam is someone sent a lot of email to people, most likely soliciting, trying to sell you something which is called spam. And your router can be programmed to not sending you those spam. Or sometimes your router is not sure, so they're still going to send it to you, but going to send it to you to a spam folder. Then that will be another way for the router to do it. Web-based email. Oh, email are all internet-based. So, this is kind of unnecessary, huh? Email are all internet-based. Internet, sometimes we use a different term, says web. Email components and action. To someone, we all know that. CC someone, we know that. And BCC, you can use BCC. This is like a block CC. And using the BCC is the receiver will not see it. For example, a customer send me an email, and I respond to the customer email, but I want to BCC my boss, so my boss will know what's going on. But I don't really want my customer to know that because it's a company policy. So anything, then I just say BCC. Subject, yep, we know that. And this is kind of funny. I saw one guy who really liked to write a reply under the subject. So the subject turned out to be very, very long. you send, for example, you send an email to your boss. Hey, tomorrow is Friday. I have some personal stuff I need to take care. So your subject may be off request Friday. Okay, you have an off request Friday. That's cool. Then your boss return. Just change the subtitle. Say off request Friday, and next to that just say okay. Send back to you. that was very, very creative and funny, but it works. It works, and it's really saving time. So later on, you check this email. You just see the title. The title was off Friday request, and next to that is okay. Okay, so your boss okay. You don't have to open up you don't need to see the content of what's going on. Your boss agree or disagree, so something like that. then your boss maybe put it on like off request Friday. Okay, then your boss says why. Okay, then you use the same way. The title is say personal. Then your boss reply okay. Okay, then later on you just read the subject, you understand the whole story. That was something different. I saw one guy use it. I think that will work. So you don't need to have a content attached file. Yeah, attached file is very important. And attached file, it has bring up lots of problems. A hacker may send you an email and with an attached file. A hacker pretending it's your friend or your boss sending you an email with an attached file. Say, hey guys, you need to open up this attached file and do something. If you're not sure that's from your boss, then you better pick up the phone, call your boss. Have you sent me or text? Nowadays with mobile phone text, I just received an email from you. Looks fishy. I don't know what's going on. Doesn't look like you. If that is you, let me know. Text, and your boss say, yeah, that's me. Or no, that's not me. You don't want to open up that attached file. Should you open up that attached file and turn out to be a hacker's attack, that turn out to be an executable file may wipe off all of your computer info. Turn out to be you have a new computer. Would you be happy about that? Hey, I got myself a new computer. No. All of your info are lost. All your email, all the file, everything. Computer is useless unless they have your info, right? A new computer is useless. I mean, once you have your photos, your email, your files, then that's that's valuable stuff. So I'm going to wipe off. So be careful about this attached file. We talk about hackers attack via email. Pay attention to attached file. And also pay attention to link. Sometimes they say, click this link. You click this link, then turn out to be an executable file, also going to wipe off all of your computer, make your computer a new one. That's terrible. Talking about Lang-Chi and Tong, and be brief. This is more business stuff here, but this is very, very, very important. This is very, very important for an email usage. Well, I have seen many email receiving from people, like I'm a professor, so for my student send me an email, say, Dr. Oh, okay. Then later on, my student is not happy because request something. I say, no, going to send me something without a title. There's no more Dr. Wu, just you and me, that kind of stuff. That's the language. I mean, I always say hi someone, even I'm not happy. I still say hi someone. I keep saying that way. That's my style. So you have your own style and use it. Tong is, give you example, right? Say, for example, this guy is John Doe. So I always say, hi, John, something. That make it a little bit informal way to talk to people. I say, hi, John, I received your email instead of John. Oh, that's John, hi, John. You see the tone differences here? And I always come up, most of the time say, thank you for the email. Then I talk about something. Not like, even if I want to reject the request, I say, thank you for the email. I have considered, I would say, I cannot say yes to your request. Something like that. That's the tone. The tone is important because we don't have a face-to-face. When you do a voice conversation, you have tone. People are based off your tone to know the difficulty. You say no, and say no, and no. They're different tone. The one is more commanding, right? We all see that. But once you type in your email, you say no. That's a no. So people may read it no. People may read it no. Okay, that's your tone. Be brief. It's very difficult. People sometimes send out, I'm sorry for this long email. Well, okay. If you make a consent, you make a consent. If you cannot make it consent is different to say short, but have the needed meaning in there. Then make it sense. Yeah. If you are a boss, a leader, I really said that all the leaders have to have the skills to write and read the email. Sometimes I hear people say, well, I have email behind for 2 days. Meaning I read some email, but for the past 2 days email, I haven't had a chance to read it yet. That's bad. That's bad. May not be because of you. Maybe people send you too much of email. So if you can write a concise, short, brief, concise email, you're good. You're good. It's not so easy, and still be polite, be firm and polite, so people understand what you're talking about. The biggest problem to me for the email is not necessarily long email, but it's the term. Too many abbreviations. You don't have a clue whatsoever. They're using too many abbreviations. Then you don't understand. They assume you know, but you don't know. That's the company's own terms come up with. So that's really make it difficult to read. So I would suggest people to make it more clear. real-time communication. Email is not real-time. That's the beauty of email. It's not real-time. We need real-time communication and non-real-time communication. Today, typically, you don't pick up a phone to talk to someone if you can text them first. That's a text. Text is not a real time. So people may see your text in 5 minutes, in 2 hours, even 1 day. If that is not kind of urgent, then people can respond. If you under some kind of urgency, you have to talk to someone, pick up the phone and call that guys and talk. Otherwise, you can use a non-real-time communication like an email. And with the more and more use of text message, then email may not be read. Some people don't read their email. They do read their text message. So in this case, you may text them, say, hey, I have just sent you an email. Please read it. Whoa. Yeah. And IM, instant message. This long time ago, this is the ICQ, created by a company in Israel. That's a ICQ. Later on, we have this instant message, been a trial. Instant message is then later on you have a short message. Instant message in here, I use it when I am have a voice conference call with customers, with my boss. I talk to customers, and the customer asks me one question: can you deliver this Friday? And my boss may, ICQ me, say no, say 1 more week. In this case, the customer will not see it, but my boss gave me some direction. So I say, sorry, sir, I think we will need 1 more week. So that will happy. Instead of my boss come out and talk, because the customer asked me, my boss answered that for me. It doesn't look good to me. It looks like I'm dumb or I don't know what I'm doing. So this is I am serve this purpose in the industry, and I use it a lot, and it's good. Video conference and voice conference depends. Many CEOs, they like video conference, but the engineers and testers may all prefer voice conference. The difference between these two is video conference, you can see it, and voice conference, they don't see you. If you are a CEO, I guess you are dressed up, right, every day, so you like people to see you. But if you are an engineer, you are a tester, you're not dressed up. You don't have to. And during the video conference, a CEO can focus on the video conference, but an engineer or tester may also want to keep working on their task. Whenever they hear something about themselves, they need to respond, then they respond. So a voice conference and video conference, which way is better? Really depends. Nowadays, we have many room meeting. And room meeting, you can have a choice, right? You want to show your video, or you don't want to show your video. If you don't want to show your face, your video, then turn out to be, to you, it's a voice conference, right? And the presenter still can show you the thing they want to present, not like a voice conference. Turn out to be a video conference. They can show you slideshow. They can show you a piece of video. So it's a better way, that kind of a conference. We're talking about video conference with the capability for you to turn off or on of your video. That's the best. And also your voice. That's the best way. And long time ago, for the video conference, they don't have such a function. If you are in a video conference, like people can see you, yeah. Voice over IP, that's new technology. Voice over Internet protocol. This technology had replaced PL, public land-based network. At first, since 1920, we have found the phone go via a telephony switch. Most commonly used is AT&T 5ESS. That's like a $1 million phone machine. So your phone call will be routed from Dallas to New York via 3 or 4 of those $1 million machine. It's expensive. Later on, about 25 years ago, the new technology called voice over IP, they don't route it in the middle via those phone machine. They still needed the phone machine to both end. I'm talking, and I dial a phone number, I dial a wrong number, then the switch told me, hey, they give me an announcement, the phone number you have dialed is incorrect, try again, something like that. But in between, they are transit machine. They don't have to have that kind of function. In this case, we have in between phone machines, we just use a router. The router will cost you several $1,000s comparing to $1 million telephony switch. Thousands and millions, that's a big difference. You will cut down the price dramatically. We call voice over IP technology. We use routers instead of the legacy telephony switch in the middle of the transaction for a voice call, voice over IP. And using the same technology, this is similar to we are sending an email, internet. When you are sending an email, it's cheap. It's very, very cheap. The email, they just have some routers. Routers are cheap. Using routers to route it from point A to point B. So that's your voice over IP. Long time ago, it's like 30 years ago. In the US, you only have AT&T, MCI, and Sprint allowed to provide long distance calls. And it was very, very expensive. How expensive? If you talk your friend in New York and you are in Dallas, you pick up a phone, talk to your friend for 10 minutes, it may cost you $5. At that time, $5 is big money. Even today, if you talk to someone a long distance for 10 minutes, going to cost you $5, you say, no, I'm not going to do that. I'll use a Skype, SKYPE, that's free. How come Skype can be free? Skype is over voice over IP. I'm using the voice over IP, then those inexpensive routers going to route my call, just like rerouted my email from point A to point B. Your voice sample turned out to be 0 and 1. Your email turned out to be 0 and 1. Computers only know 0 and 1. There's no difference to the computers. So that's the new voice over IP. So what's voice over IP? Is the using the way we are routed your email on the internet. Now we are routed your voice sample on the internet. That's what I want to share with you.